All right, let's get started. Since it's the first lesson that I'm seeing you guys for this week, and actually the only lesson I'll see you guys this week because of Good Friday, let's make the most of it. So we'll start with our little korero, just to touch base and build those relationships. I'll pick someone randomly to share their opinion on whether or not it is better to be too hot or too cold. The person sharing that today is going to be Arvin.
It's better to be freezing because it keeps my body work harder to keep it warm, thus burning more calories.
I like that. I haven't actually thought of it that way.
It can also help improve my immune system and my cognitive system.
I like that. That's a very a scientific reason to why you prefer being too cold. Just curious, out of the class, how many said too cold is their answer? They prefer to be too cold. Looks like a majority. How many said they prefer to be too warm? Too hot?
Too cold.
Not as many. Yeah, that's what I thought. My reasoning was not as scientific. My reasoning was that it's easier to layer when you're too cold and to change and to fix too cold. It's a lot harder to fix too hot, especially if it's humid. And with sitting in front of a heater, you instantly feel warmer, but when you sit in front of an air conditioner, it takes a long time to get that body temperature back down. So I think that's a very, very reasonable reasons. Interesting. That's why I like to do these random questions, just to see what we should have in common and debate. All right, micro goal for this week is going to be Minna. Minna. What's your micro goal for this week? You don't have one. Well, you should probably think of one. It is the last week of term, and you probably have some assignments due for one of your subjects, I would say. Huh? No? All right, well, then I would just say keep up with everything. Oh, maybe make a study plan for the holidays? Would be a good one? Sorry. Anything else that anyone wants to share before we move on? No? Oh, yes, Ruben. It was whose birthday? Very good. Happy birthday. Alrighty. Anything else? I just realized my thingy isn't gonna present properly in my next slide, so let me fix that. Yeah.
Zara's party was on Sunday.
Zara had a party on Sunday. Zyro.
Yeah.
That sounds good. Hopefully you guys were invited.
Yeah, we were.
Yeah.
We went. Yeah.
Nice. All right.
Zara's gift arriving. Zara's gift is arriving.
Okay. All right. Shall we switch gears and talk about our learning? So last week we did a lot of work. We talked about precipitation reactions and writing those equations, looking at those ionic formulas and ionic equations. We also started looking at the flow chart, which is the anion flow chart, which is a little bit easier than the cation one. And the cation one is the one we are going to be looking at today. Remember, these flow charts will be given to you on the assessment, so you do not need to worry about memorizing these guys. We good? All right. Lastly is our weekly fakatoki before we get started with the lessons. So we have hi, ihu, kuri, he, ta, ta, hare, which is as the dog follows a scent, a traveler relies on the hospitality of others. Beware blindly following your nose, be deliberate and make good choices, which I think is a really good fakatoki for the final week of term. Thinking about making those good choices so that way you end the term really, really well. Hopefully you get your assessments sorted, etc., etc. Cool. And also don't blindly follow, think about things. All right, so lesson plan for today, we'll start with identifying a cation, and I'll do the write-ups to show you what to look for and also how to use the flow chart. It's basically the same thing with the anions. Then you guys will have a chance to practice it, and then we will wrap up with the Mahi choice. So very kind of casual lesson for today. When it comes to the success criteria, we're looking at number 6 and number 7. So number 6 is identifying those cations, and number 7 is writing those balanced equations. There is one more thing that I need to teach you content-wise, which is the complex ions. I'll point out where they are in the flow chart as something to kind of mention, but we won't do those until next term because I don't want to overwhelm you. But those complex ions are what you need for the excellence level. So just kind of keep that in the back of your mind that complex ions will be coming. All right, cool. So let's talk about identifying a cation. So again, we're going to be watching some videos to see what's happening. And then you guys will have a chance to have a play. And that's also a reminder for me to talk about the 2 drops of ammonia, which we'll do later, which is fun. All right, let's go to Science Scribe. And we'll close the PowerPoint. So he had a couple up here. The sandbox ones don't actually have any equations to them, and I think don't even have a precipitate to them. So these ones aren't ideal to do, but you're welcome to write them up because it's practice. The easy ones here will only go up to the merit level, just FYI, and then the normal ones are the ones that do have the complex ions, which go up to excellence. So you might want to save these ones till later, just as you guys are thinking about it. But you guys can do these ones here, and that's all going to be good practice. All right, so I said we are going to be doing G. So first thing that we notice with the cation flow chart, and I'm just going to pull up the document camera as well and make sure it is focused, is our first step is to always add 2 drops of dilute sodium hydroxide. So we're going to write that in our steps. Remember, your steps are an achieved requirement. Step 1, add 2 drops of NaOH. Now, it's really important that you specify those 2 drops because there's going to be instances where you're going to add excess, and we need to note that. Are we good so far? All right, can I move it? So first step, add 2 drops of sodium hydroxide. I've written that down. And I should also write down on the top, the one that we are identifying today is Science Scribe. Cation G. The one that we're doing? Yes. You want one of these papers? Yeah. I need to print more booklets because, like I said, the printer didn't actually print the right number. It is online if you want to edit through Candy and stuff. All right, keep going. All right, let's see what happens in that video. So there's our unknown. And this one's kind of hard to see. So he's adding the sodium hydroxide. Now, I don't know how well you can see it on the projector, but I can see it on my screen. There's like a little kind of like opaque solid that's being formed. Yeah. So that opaque white. I don't know how well you guys can see it on the screen with the data projector. You can kind of see it. All right. So going back to our flow chart, white is not very helpful to us because there are a lot of things that are white. So, observations, white precipitate forms. So I'm going down this way. Now there's lots of different choices with that white precipitate, and these white precipitates are going to look slightly different to each other. So that's why when we are doing the cations, I'm going to have you guys test all of them as practice so you know what they look like. Because you can, even though there are white precipitates, you can tell slightly differently which one's which. So from that list, again, if we're thinking about our justification, we're thinking about what it could be. You don't need to write what could and can't be. You can write one or the other. I'm going to write what it can be. So it could be aluminium. It could be the zinc ion. It could be the lead ion. It could be magnesium. Or it could also be barium. So those are my possibilities. Are we good so far? No. What are we not good about?
I'm still writing.
Okay. Remember, achieved is in red. Merit is in blue, and when we eventually get to excellence, we will do that in green. Cool. Can I move it? Can I move it?
Yeah.
Okay. So if I'm looking at my instructions, after I get that white precipitate, I need to add excess sodium hydroxide to see what happens. And then I have several different choices. The precipitate remains or the precipitate disappears. So looking at my choices, I'm going to do excess sodium hydroxide. Let's play it. So you can kind of see the precipitate over here. We've added more solution. Is that precipitate still there?
Yeah.
Yes. So since that precipitate's still there, when we go to my flow chart, I'm going down here, and I have the choice of magnesium or barium. So step number 2 was that we added excess NaOH, and in step number 2, the white precipitate remained. So that has helped narrow down my choices. Now my choices could be barium or magnesium. I've basically eliminated that aluminum, the zinc, and the lead from that step. Are we good so far? All right. Back to the flow chart. All right, so I go back to my flow chart and I see I have to have a new sample, and I'm going to be adding dilute sulfuric acid. So let's write that down on my list. Step number 3, new sample. We add sulfuric acid. And when I add that sulfuric acid, 2 things can happen. Either my solution remains colorless or a white precipitate forms. If the solution remains colorless, then I have magnesium. If it turns white, then I have barium. So let's go back to that video and see what happens. We are looking at new sample on sulfuric acid. So there's my new sample. There's the sulfuric acid. Do we see any precipitates forming? No. So I'd write down no precipitate. So from that information, if I have no precipitate, that is magnesium. Shall we check if we're right? All right, let's check our answer. So done. Magnesium ion, you're correct. Yes. All right, shall we finish the write-up? All right, so now that we know it's magnesium, we have to backtrack and figure out what this white precipitate is, because you can't pass unless you tell me what that white precipitate is. So I have magnesium as my cation. What's my anion going to be if I look at what I just added? I had sodium hydroxide. Do I want the sodium or do I want the hydroxide in this case? The hydroxide, because I want a positive and a negative. And so sodium's already positive, so I need the hydroxide. If you wrote that, you would be marked wrong because you don't have the formula. So what do I want you guys to do is back up. Write the word. Magnesium hydroxide. I can pass you on that. So that's the backup. Remember? But the correct formula you should have A2. Because it's -1 and +2. All right? That's all you need to do for the achieved. You don't need any of this justification stuff for the achieved. but that's super easy. Let's try to get the merit. All right. What I need for merit is the equation. So remember how I said with the equation, start with the precipitate. So magnesium hydroxide, and then I write a S behind it because that tells me it is solid. All right, and then all I do is transfer it back and write the ions down. So magnesium, I would be writing Mg2 plus, and then AQ for that aqueous. And then with the hydroxide, it is OH minus aqueous. Now, how many do I need? 2. And where do I put the 2? In front. All right. Now I've gotten my answer up to the merit level. Easy peasy? Yeah, I thought so. All right, there's a couple of things I need to point out on the cation flow chart, just so you guys are aware of where we're going in the future, and also to point out some like little asterisks. Can I move this now?
You want to?
Do I want to? Okay. So, with this cation flow chart, there's some things that are slightly different with this than the anion one. The first one you'll see is that you'll see the word adding excess. Add excess. See where else is there? Add excess. Add excess. You see how there's several different spots where it says add excess? So what you're doing, it needs to be very clear, and I would treat it as 2 separate steps. Step 1, the 2 drops, and then step 2 is the add excess. It's really important that you separate them as 2 separate steps because you're trying to see what's happening with the precipitate. So basically what we're looking for is a precipitate forms and then disappears. And I'll just shift it down here. Precipitate forms, then disappears. We see it up here as well. Precipitate forms, then disappears. Precipitate disappears. You see how it's multiple sections where those precipitates are disappearing all of a sudden? Those sections are your complex ions. That's all I want to say for that at this point, because I will do that in its own separate lesson, complex ion, because that is the excellence requirement. Are you okay with that so far? The main thing that I would want you just to do then in the write-up is just write up that it disappears, write up if there's a precipitate, that's all, okay? Because you can still get it up to the merit level without the complex ions. Are we okay with that one? All right. The second thing that I wanted to point out on this flow chart is the use of ammonia, and how you have to have 2 drops and then excess. So you see 2 drops of ammonia and then excess. A precipitate forms and then disappears. And another example, I'm trying to find ones that would have this example. Down at the bottom. Add 2 drops of the ammonia, precipitate forms, then disappears. Add 2 drops of ammonia, precipitate forms, and then disappears. So the first thing is, what is those precipitates? Like, why are precipitates forming with ammonia? Now, here's something that's important to remember with this 2 drops of ammonia. The precipitate with the 2 drops of ammonia is not with the ammonia. So I'll write that down over here on our flow chart so we remember it. The precipitate with the 2 drops of ammonia, it doesn't have ammonia in it. It has hydroxide. So you guys remember how I said if we figured out this was copper, and that's my cation, I need an anion. When I look at ammonia, I don't see an anion there, right? So now I'm telling you where your anion is. It's with hydroxide. So the thing to remember is that ammonia is a weak base. And then I'm going to do a little asterisk so I can show you the equation, because I'm running out of space over there. So what happens with our ammonia when I add it to water, and I'm just going to do a little asterisk so that way we're moving from this thought over here. I have ammonia, and I add it to water. This is, you see how there's a two-sided arrow? That means reversible. So what's going to form is the ammonium ion and the hydroxide ion. And that's where the hydroxide is whenever you have those 2 drops of ammonia and then a precipitate. Would you guys like me to do one as a write-up example? So you can see it?
Yes.
Yeah? Okay, I can do another one. Cool, let me get another sheet. Does anybody else want another sheet? So no, I didn't have enough. We're good. All right. I'll do another video to show you what I mean. Okay. So we'll do another science scribe video. All right, we'll do D. Science scribe. All right, so I've written on my piece of paper that we're doing science scribe cat ion D as our next example. So my first test always when I'm dealing with my flow chart is I add 2 drops of my sodium hydroxide. So let's write that down as my achieved. Are we good? Keep going. Watch the video. All right. So we go to D. We watch him add 2 drops of the sodium hydroxide. So here's my unknown. It's a slightly blue color. We've added a couple of drops of our sodium hydroxide. And what do we see? Blue precipitate. So we're going to write that in our observations. All right, blue PPT forms. All right, when I'm looking at my flow chart and I'm thinking about process of elimination, let's see what's happening. So 2 drops. It wasn't white, there wasn't no precipitate, there wasn't a green one, there was an orange one. There you go, blue. And what does it suggest blue is? Copper. So I'm going to write that down that it's probably copper. So let's confirm that. Because we're scientists, we want to double check. All right, looking at my flow chart, my next step is to confirm it. So I need a new sample, and we're going to do 2 drops of my my ammonia. So that's why I'm breaking it up into 2 steps. New sample, and we're doing 2 drops of NH3. And then my next step, number 3, is to add excess. So I'm just going to start setting myself up. I know on the flow chart it's being treated as one big step, add 2 drops, then add excess, but I like to treat it as 2 separate ones because each one of these will have their own equation. Are you okay with that? Alrighty. So let's go watch the video and see what happens. So we have we have a new sample, 2 drops of of ammonia. See what happens? So there's my new sample. There's my 2 drops. And it's very important that you just do a very few number of drops because we're going to be adding excess and that's going to change what happens. So what do I have? Blue precipitate again. It didn't disappear because we haven't added the excess yet.
Oh.
So blue PPT forms. So still probably copper. What's the next step after that? Is to add excess. Shall we see what happens?
Yeah.
All right. So now we do excess ammonia. So here's, let me pause that. Here's what we started with just at the end. So it's picking up from where we left off. And that's the excess. So what happened? It turned dark blue, and what happened to the precipitate? It disappeared. So we got to write both of those things down. So precipitate disappeared. I'm gonna write blue precipitate. And solution turned dark blue. So what does that confirm to me? Confirms copper. So this ion is copper 2. All right, shall we check to make sure we are right? We've reached the end. Yes, we are correct. It is a copper 2 ion. Cool. All right, but we are not done yet because we need to go back and write in our precipitates and the equations. So in this first example, oh, come on back. Might need to restart the program. Visualizer, where are you? There we go. All right, so copper is our cation. What would be the anion? If I added sodium hydroxide. Hydroxide. I would be marked wrong. What do we need to do? Brackets 2. Back up. Copper hydroxide. All right, equation time. Work yourself backwards. So, CuOH2 solid. If I work my way backwards, I would have the copper 2 ion, aqueous, and how many hydroxides? 2. Aqueous. Oh, let me move it over so you guys can see it. All right. Number 2 also had a blue precipitate, so I need to identify it. So I know I have copper, but if I look at my sample, I added ammonia. So what's my anion?
Ammonia.
Not ammonia. It is the hydroxide, because remember how I said ammonia is a weak base, and the anion that you have when you have those 2 drops is the hydroxide. So you're writing the exact same equation that you had above again. Does that make sense? Or do you need me to repeat that? You don't need to show me the equation of the the ammonia acting as a weak base. All I need to see is the hydroxide. But I'll make an extra note on there just because in case you guys are confused. This hydroxide came from NH3 reacting with water. NH3 is a weak base. And I'll write the equation down. That's where that's coming from. You don't need this on the assessment. I'm just trying to explain where it's come from. All right? Don't need this on the assessment. Are we good?
No.
No? What can I do to help? I just heard a no from Klein. What can I do to help? Nothing? Do you want me to re-explain it again? No? We're okay? The main thing to remember is that if you put 2 drops of ammonia into something, you have hydroxide as your anion.
Okay.
Okay? That's the summary of my statement. 2 drops of ammonia equals hydroxide. Okay? I don't want to see any weird stuff where you have the ammonia in an ionic compound. Okay? Don't want to see any of that weird stuff. All right, shall I leave that up? So I can see you guys are still writing. All right, can I maybe say one more thing? Or do you guys want to digest that first? I can say something? Okay. So you see how in this step here, the blue precipitate disappeared and turned into a dark blue solution? That is because of a complex ion forming. And that is going to be your excellence. And then number 3 would be your complex ion equation. So that's what you need for the excellence. So everything in red is the achieved, everything in blue and red would be what you need for the merit, everything in all the colors, minus that pink stuff, is what you need for the excellence. I will talk about complex ions next week, or next term, okay? I just want us to write up things to the merit level. Are we okay with that? Because I don't want to overwhelm you. All right, does anybody need any more to see off of that page, or can I move it? Are we good? Can I change it? Yes? Okay, are you guys ready to give this a go?
Yes.
All right. So, I want you guys to start practicing identifying cations. With these cations, you're going to be grabbing some slightly different reagents. They're all laid back out on that table over there. So same sort of thing. Grab a test tube rack, test tubes, ice cream container. Grab one of each solution. You will be packing up your solutions today and putting them back when you found them because obviously we're going on holiday. What I will do in this case is I'm going to take out 2 bottles, and I won't treat them as unknowns, because I want you guys to start telling the difference between the white precipitates. So what I'll give you today is magnesium, which we just did, and barium, so you know what the difference is. Does that sound like a good plan? So they'll both be white precipitates. They'll both be very similar. Neither of them have complex ions in them, so that makes it a lot easier for you guys to do. So instead of us using pipettes, we'll just use bottles. You will know which one's which, because I want you guys to know what to expect to look for. Okay? Does that make sense? So we don't have to worry about cleaning and doing any of those pipette stuff. Make sure you put the waste down the sink and flush it with a good amount of water. Don't leave the solutions in the ice cream containers, because we're not going to be reusing them because you guys are going to go on holiday. Put them on my front table. Make sure you grab your goggles.